Intervals of increase and decrease, section 1.3. Again, we'll go back to the height of the rocket at time t seconds after fuel runs out. H of t is negative 16t squared plus 32t plus 48. And from the graph, the interval, the height of the rocket appears to increase on the time interval from 0 to 1 second. So here, this first time interval, it looks like we have positive slope. The height of the rocket is increasing on that interval there. And it appears to reach its maximum of 64 feet after 1 second, its maximum height, and then decrease on the interval from 1 to 3 seconds. And then it reaches its minimum height of 0 feet after 3 seconds. Okay, so so again in the book, many of the examples are sort of generic functions. So here I have a generic function, y equal f of x, and I don't have a formula for it, but I'm given a graph here. And so let's identify some of the features of the graph. First of all, the y-intercept is 1 or 0, 1. That's where the graph crosses the y-axis. You could say it's 1, or in coordinate form it's 0, 1. The x-intercept is 2.5, or in coordinate form at 2.5, 0. That's the x-intercept. And on what open intervals is f of x increasing? So increasing when x is between 0 and 1. They have a positive slope there. And it's also increasing when x is between 3 and 4. So this will be 0, 1 union 3, 4. And you only give the x coordinates on intervals. On what open intervals is f of x decreasing? So it's decreasing. Well, this goes, if the graph goes to the edge of the graph, we assume it keeps on going in that direction. So it's increasing on minus infinity to 0. There's a negative slope here. And also from 1 to 3. It's decreasing there. And what open intervals is f of x constant? That means it's horizontal. So from 4 to infinity, we have a horizontal graph, and it's constant there. It's 4 infinity. Relative or local minimum and the corresponding values of x. So a minimum would be local minimum. It means it's smaller than nearby points. It's the bottom of a valley would be a minimum. So we have local minimum of 1 when x is 0. Y is 1. We have it's lower than nearby points here. And likewise, we have a local minimum of negative 2. Y is negative 2 when x is 3. Absolute minimum. Okay, so that would be the smallest y value on the graph, which would be at negative 2. That's the absolute minimum. The local maximum, relative maximum, or local maximum, that'd be the top of a hill or top of a plateau. So here we have a hilltop. That would be when so the y value here is 2 and the x value is 1. So local maximum of 2 when x is equal to 1. And we also have another local maximum of negative 1 here when x is at least 4. So this is here we have a hilltop, and here we have a plateau that's higher than nearby points. So it's a hilltop here and a plateau here that are higher than nearby points. absolute maximum. Well, there's no absolute maximum because, again, we assume if the graph goes to the edge of the graph, it keeps on going in that direction, and it looks like it's going up to infinity. So there's no absolute maximum.